All right, good afternoon, everyone. Actually, attendees joining, which is great. I hope you're all well and mostly avoiding going stir crazy with the lockdown going on. I'm going to kick off in just a minute or so. We'll give some other attendees a bit of opportunity to show up, and then we'll get going. Okay, thanks for joining. Let's get started. So this is a webinar on architecture for security on AWS. I think it's important to start with a question about who the hell am I and why am I talking about this topic and why you should listen. So I'm the founder and the CEO and the CTO of the Scale Factory. We'll talk about who we are in a second. I've been working in hosting and infrastructure for about 2 decades at this point. Initially in the ISP industry, and then into startups building mobile applications, and then into consultancy, where we've been working on sort of DevOps and infrastructure AWS problems for almost 11 years, or over 11 years at this point. Some sort of webinar housekeeping stuff today. I'm joined today by my colleague Mike, who's also on the call. He's going to be keeping an eye on the chat, so you can ask questions in there as we go along if you'd like, and Mike will do his best to reply to them. You can also, if you want a question to pop up for me to answer, you can use the Q&A button at the bottom of your Zoom window to do that. That will pop up on my screen. If it looks like a clarification question, I'll do my best to answer it as I'm talking, but otherwise there's a Q&A section at the end of this webinar in order to get into that in a bit more detail. You can see each other's chats, I believe, so do feel free to talk amongst yourselves if you'd like to introduce yourselves and who you are and what you do, what you're hoping to get out today. That might be a good way to meet some of your fellow webinar people. This is our second webinar. We would typically do these sorts of events as in-person events, but we're obviously online along with everybody else now. So I think it's important to do the networking thing that we'd otherwise miss out on. We are recording this webinar. The recording will be available to you after the session is ended. I think you'll need to email me for the URL of that, but if you'd like to catch up later, then that is possible. And the slides as well I'll make available to you if you need. So don't feel like you need to take copious amounts of notes. All of the information will be available to you. One small bit of housekeeping. Obviously, I'm in my apartment. I'm right by the front door. I think I'm expecting a delivery, so if that goes off, I might pause for a couple of minutes while I do a socially distanced pickup of a parcel before we carry on. So I'll apologise in advance if that's necessary. It's probably dinner, which is obviously important. Who are the Scale Factory? We're an AWS advanced consulting partner. We've been a partner now for sort of 4 or 5 years, I think, and the advanced tier for something like 3. We were a launch partner as part of the Well Architected program, which I'll talk about a little bit later on. And within the team, we have 50 AWS certifications. So I and the rest of the team have gone through the exams and at least as far as the paperwork is concerned, can claim to know what we're doing. We're also a Kubernetes certified service provider. So if you have Kubernetes challenges, particularly in the security realm today, then we can probably help you with those. And if you are selling to or part of the public sector, we're also an HM government G-Cloud supplier. So we can you can purchase our services through the G-Cloud framework if that's something that you care about. We like to put people first, so here are the people. We're a team of 19. We're not a huge organisation. We do punch above our weight. We're very effective at this size. Most of the team are engineering focused. We have a bit of administration and project management, but the majority of us are engineers, consultants living and breathing the AWS platform every day. We've worked with a number of different clients. You probably recognise some of these logos, Expedia and ITV being the most notable, I guess. We work across sizes of business, so we've worked in those sorts of enterprises. We're also happy working with SMEs and startups. The technical problems are often the same. The kind of governance and sort of people problems that often look different, but we're quite happy working in all of those worlds. We're also happy working across the breadth of industry sectors. So we're quite happy in e-commerce, entertainment, media, finance and healthcare, automotive, like you name it. We've probably done some of that work. I call out, I guess, healthcare and finance in particular, because I know we're talking about security today, and the compliance landscape is often one of the things that lends itself to thinking seriously about security. So maybe some of you on this call are from those kind of areas. I mentioned well architected. Well architected is a combination of white papers and information provided by AWS on how to build good infrastructure architecture on their platform. There's also a review tool within the console, and as partners, we can run well architected reviews with you. This is a half-day exercise. There's about 60 questions in there. We use it as a jumping off point to discuss in more detail about various architectural topics and the challenges that you're facing. We joined this program as a launch partner in April 2018. Since then, we have completed more than 200 reviews. So we've seen a lot of architectures and have a lot of understanding of the common mistakes that people make in putting together their platforms. We're actually one of the leading partners worldwide in terms of the number of reviews that we've performed in that time. So you're in safe hands if we do that with you. We're very experienced in that area. So well architected covers 5 pillars, they're called. Security is one of those. We always cover that early on because that's an important thing to think about. But the review also covers reliability, performance efficiency, cost optimization, and operational excellence. So if you have any kind of concerns about whether you're doing the right thing in those areas, then a well-architected review can really kind of shine a light in those dusty corners, or give you some more things to think about. And I'm hoping that the content today will give you some things to think about as well. So the agenda today, I'm going to be talking for somewhere between an hour and an hour and a quarter in terms of content, or at least that's how long this took last time I ran through it. It's going to be a fairly deep technical dive. It's covering quite a lot of AWS products landscape. So we are going to be sort of getting into the meat of the platform, and I'm hoping you're going to have something to take away from this, whether that's some idea of things that you want to research a little more, areas that you know that you're sort of not doing great on and would stand to spend some time on. And I'm going to be covering sort of who is responsible for security, really. We're going to talk about leveraging the AWS platform and what I mean by that. We're going to talk about the 5 areas of security, which is how the well-architected documentation covers security, and it's a good taxonomy of the security services, so it's worth thinking about it in those terms. I'll talk a bit more about well-architected reviews, and then there's some room for Q&A at the end. So there's if you, as I say before, if you have any questions as we're going along, feel free to ask them in the chat, and my colleague Mike will do his best to answer those, or I will answer things online by the time we get to the end of the session. So let's start by asking the $64,000 question. Who is responsible for security in your organization? Well, is it the CIO, maybe the CSO? Is it the CTO or the head of IT? Is it the developers? There's a whole bunch of different potential answers to this. Really, you are responsible for security in your organization, regardless of who you are. Security is one of the things that you need to be concerned about, because really security is everybody's responsibility. At every level, there are things to consider in terms of security, and you need to be aware of those things and to bake those into your working life, really. Werner Vogels, who's the CTO at Amazon, says that security is job zero, and I think that's a fair assessment. It's the thing you should be considering early on. And so this is why we talk about architecture for security, because architecture implies a level of design and planning. And it's very often much easier to build security in at the design phase than to try and paper it on later. It's not impossible to add security to an existing platform, but often you have to rethink quite a lot of interactions and systems in order to do a really good job there. And so it is easy to build this in from the beginning. I'm going to be talking to you really about AWS components that are available to you more than design patterns in particular. The design patterns are sort of implied by some of the components, but there's way more detail on design patterns for security if you're interested, and one of my team can walk you through those after this if you're interested. I like to call out the State of DevOps reports. For those of you unfamiliar, this is an annual survey run by an organization called DORA, which is now part of Google. And for sort of 6 or 7 years, they've reviewed the practice of operations teams as far as their sort of hands-on work is concerned, and uses that to group operations teams into low, high, and elite performing groups. And this is based on metrics like the frequency of deployment, mean time to recovery in the event of failure, the defect rate, like what percentage of deployments fail. And it's the only empirical research of its type within the DevOps field. I really like it because it lets us use real peer-reviewed science in order to call out why DevOps is an important practice to adopt. Previously, we would have to rely on the fact that it was just dogmatically the right thing to do. Today, we can point at numbers and say, if you adopt these practices, you will probably become a better performer in terms of software delivery. And one of the things that the State of DevOps report found, I think in 2018, was that the elite performers in that taxonomy build security into their processes and to their change processes. And this is sort of what I mean when I'm talking about designing or architecture for security. It's we're building security in from day one. It's important, I think, to talk about how we work, the sort of philosophy that we engage when we're going about helping customers build things or build things securely or secure them. We put people first. That's one of our sort of value zero, if you like. Security can often be seen as a sort of impediment or a roadblock, and really we think that anything that we do in the infrastructural space should on average make people's lives easier and not more difficult. Customers, operations, developers, all of these groups that contain people, and people have feelings and concerns and just want to do a good job. And so we seek to support those people in doing a good job with the work that we do. Matching the solution to the workload is really important. Context is everything in all architecture, in all sort of technology decision making. If you don't have a good context for the work that you're doing, you're going to make the wrong decisions. And so we like to understand the business context of something that's going on. There is no point if you are, let's say, Twitter for pets, in having a security posture that is as strong as, for example, somebody that's processing personally identifiable medical data. Every problem has a particular context, and your decisions need to be driven by that. Leveraging the AWS platform, I've got a whole set of slides on that. The main takeaway, I think, is to not fear platform-specific features. There's often a lot of talk about multi-cloud, typically by people who are selling you a solution which is multi-cloud or a product that will help you become multi-cloud. I think those sorts of solutions often suggest against using features that are specific to the platform that one of the cloud platforms that you're deploying to, and I think you should use those features, and I will explain why as we go. Infrastructure as code is something that we've done since our beginnings. Like in 2009, we were using Puppet on our first infrastructure build. I think the DevOps principles of including automation are really important. So everything we do has automation baked into it. As a sort of repeatable thing, it's important to automate stuff. and iterate. We are aware that things change, and change is really the constant in our sort of busy business landscape. And so we seek to continually improve everything that we do. So, and iteration is an important way of doing that. So you have to be able to measure the things you care about, make some changes, see whether the things you care about have got better, and work on from there. This isn't a sort of one-shot exercise where you're going to get the thing up and running and then you're going to leave it alone. It is important to continue to change it where necessary. So let's talk about leveraging the AWS platform. I know that leverage is a slightly kind of difficult word because it's thrown around by management people really poorly. This is the real kind of use of the word leverage, which is if you leverage something, you can apply a small amount of force at one end and get much bigger results out at the other end, in the same way that a mechanical lever would work. And so using the things that the platform provides you, and not succumbing to the idea that vendor lock-in is a thing that you need to worry about, allows you to move quicker and adopt less complex solutions, and reduce the number of vendors that you deal with. Reduces the complexity of your platform and your relationships, and something that is more straightforward. The easier something is, the easier it is to understand and reason about the risk involved. So I'm advocating here for properly using what the platform provides. Some of you may have seen this sort of graph before. This is what we call a Wardley map, after Simon Wardley, who created the idea. The general shape of this diagram is that from the top of the graph you have the customer, and the further down that graph you get, the further away from the customer you get. So that's the value chain. In order to support the customer, there are things that we provide, and those things rely on other things, and so on down the graph. On the left-hand side of this diagram, there is things that are in genesis. So the left to right is the evolution axis. So things that are in genesis, in the genesis area of that graph, are things that you're building yourself. So you can't buy it. It's not a product. You've got engineers sitting down, typing on keyboards, making stuff happen. And the nature of technology is that things that we kind of make up ourselves like that, over time, if they are applicable to multiple other people, then they become sellable as products. And so you go from genesis to taking something and maybe customizing it a bit, to buying it as a product, to buying it as a commodity. I hope that's clear. It's a bit difficult to explain without sort of actually pointing at things. But if you look at this is a 2009 era Wardley map for how you would run a highly available MySQL service. So in 2009, I was deploying infrastructure for a startup called Songkick, and we needed a MySQL cluster to run their application, and that needed to be highly available because they wanted to be available all the time. And so we built a MySQL cluster that sat on some compute and some storage that we bought as products from Dell or Sun or whoever it was we were buying equipment from at the time. That was put into a data center, which provided for us networking and power that we bought from commodity vendors of those things. In order to manage the highly available running of the database, we had to have some monitoring. We had to provide some scripts to manage the failover. And we didn't write those. Those are open source tools that we pulled down off of the internet, but we did have to customize them to work in our particular environment, hence where they live in this sort of custom area of the evolution axis. And then we also had to write configuration management scripts to pull all this stuff together. And although Puppet itself, the tool we were using, was a product, we were writing code in that language to make the failover situation work. And so the config management was engineering time, and so we spent the time on that. And the idea here, in the most general of terms, is that the stuff on the left-hand side is expensive to do in time, and the stuff on the right-hand side costs you money. So we were spending engineering hours on config management. That was expensive engineering time. We were spending money on power and networking. They were things that we could buy just off the shelf. If we decided that the networking was not priced very well, we'd just buy it from another vendor. It would look exactly the same, hence the commodity nature of it. So that was 2009. Today, an equivalent graph or an equivalent WARDDUTY map for this looks like this. Right, so we're literally at this point just buying commodity database services from Amazon using the RDS Aurora product, which means that all that time that we spent on building config management and spent on writing monitoring and failover scripts and configuring servers and all that kind of jazz, we don't have to spend that anymore. So we've freed up our kind of expensive thinking resources, our expensive engineering resources, to spend time somewhere else. And where are they going to spend their time? They're going to spend that time on business value generating activities like adding features to your product. And so leveraging the platform here really is about saying, let's just buy this thing from Amazon instead of managing the automation and the failover and the infrastructure required to run these things ourselves. It's a fairly extreme example, but this is sort of broadly the thinking. And if you look at the Amazon product suite, there's a whole lot of categories of things. You can see database in there on the left hand side in the middle. There are more than just RDS Aurora as options. It's a whole pile of stuff. And as a rule, if you're building products of some kind, if you're deploying into the cloud any software that you haven't written yourself, you might be doing that wrong. That's a smell for maybe spending too much time in the sort of Genesis or customization areas. You could probably instead be buying something equivalent from AWS and having them run it for you, so that you can get on with building business value. So, for example, it would be folly today to deploy MySQL yourself. It would be folly today to deploy MongoDB yourself. If you're building machine learning models using TensorFlow, you should probably be using Amazon's machine learning platform in order to avoid having to spend all that engineering time on running this stuff yourself. And this is a sort of an example of what we call the shared responsibility model. And this is something that, from a security perspective, you definitely need to be familiar with, because there are certain parts of the ecosystem that you need to be worried about the security of versus certain parts of the ecosystem that AWS will worry about. So here, AWS have responsibility for the security of the cloud, so they can make assertions about the security of those compute resources or those database services. You as a person who's building an application is responsible for security in the cloud. So your customer data, you have to make good design decisions with how you use the AWS platform in order to ensure the security of that data. It is possible to drop a load of customer sensitive data into an S3 bucket and make that bucket public. It's not Amazon's fault you've done that. If that data leaks out, that's your responsibility. It is the customer's responsibility to manage identity and access management and the security of your own applications. It's your responsibility, if you're deploying EC2 instances, to manage the security of the operating system, and to make choices around file encryption and so forth. There is a question just popped up in my Q&A window from Nicholas. Is there an OAuth type service? Yes, there is. There is a service called Cognito which will handle some of that. I'll let Mike answer that in a bit more detail in the chat if he'd like to do that. So the 5 areas of security, as far as AWS well architected is concerned, are these 5, and I'm going to talk about the product offerings that cover the technology in each of these areas. And at the end of each of the areas, I'm going to ask you some questions, or give you some slides with questions on, so that you can assess for yourself, like where am I in my own security practice relative to these 5 areas. So we'll work through each of these 5 in order. Identity and access management. Now, this is really foundational. And this is one of the first things that you have to touch as soon as you use anything in the cloud. It's also very vendor specific. So again, going back to the kind of vendor lock-in scenario, you can't do anything on AWS without immediately touching something that is AWS specific. And that is the way that they integrate, or the way that they implement identity and access management. And really what IAM is about is identifying principals. So a principal being either a user or a group of users or a service or a role, and then attaching policies to those principals, which then confer permissions on them. We talk about good IAM practice. If you're currently logging into your AWS account using root credentials, which is to say that you're giving an email address and a password to get into your AWS account, then you shouldn't be doing that. Good practice is to disable access to the root account, or not use it for general use. Good IAM practice says that we should create unique credentials per person. So every one individual should have a username and password pair that relates expressly to them, that they don't share. And ideally that is the only set of credentials that they do use to access the platform. They don't have multiple identities for different things. And good IAM practice, as with any security practice, really is to create least privilege policies. So only permitting those principals access to the resources that they need to be able to do the job that they're trying to do. AWS provides the opportunity to use multi-factor authentication. MFA is a way of providing a second set of information as you sign in, so that if somebody leaks or if your username and password is found out by somebody, then bad actors can't use that information to get into your account, because you have this other piece of information to provide as you log in to do that. You're probably familiar with MFA in some form or another. You might have seen MFA where these tokens get texted to you or sent to you by email. The right way to do that really is to use an MFA token or a virtual token of some kind with an application on your phone. So as I come to log in here, this is the SSO account. My username is JTopper. I put my password in, and then as soon as I've done that and hit the sign in link, I'm being asked for this MFA code. And I go to my phone and I look that up. It's been configured to provide that, and I'll put that into the window, and I get logged in. So that keeps me safe. Same applies across any service you use. If you are using Gmail, Dropbox, Twitter, Facebook, any of those kind of services, you have the opportunity to enable multi-factor authentication on those, and I would really encourage you to do so, because it's not an awful lot of extra effort, and it massively increases the safety of your credentials. We find when we're doing well-architected reviews that MFA usage is spotty. Like lots of people are using it. There are plenty of people who are not. So that's easy to turn on. One of the first things that you should go and do from here, if you find that this is that you're not doing that. One other thing that IAM can offer is federated identity. We don't see a lot of this in the field, but in this model, this is sort of more commonly used in the larger businesses where they might have an Active Directory or a Okta or something providing identity services for a lot of other things that they do. And with federated identity, you are able to configure your IAM setup such that you can exchange your Active Directory identity for a set of AWS credentials, and without ever having to set up a user on the AWS side. So in this case, you prove your identity to the identity provider. You'll get a SAML assertion back. Those get swapped for temporary credentials. And then you can use those temporary credentials to assume a role and do the work that you need to do. And so when you fire someone or you bring someone new into your organization, the fact that they are in a group and have access to a federated identity service means that they can straight away get access or not get access to the platform as required. Matt is asking, can you enforce MFA for users without it being enforced for services applications as well? You absolutely can. I've got some slides on actually how you should be using identities for applications. So I'll cover that in some slides. And if you have further questions on that, I'll let Mike pick those up in the chat room. Thanks, Matt. So also of interest to a larger businesses, or at least anybody who is running multiple AWS accounts, and there is a good reason to be doing that, is something called AWS organizations. When we first started running well-architected reviews, there was not a lot of this in use. We're seeing a bit more of it now, and it's one of the things that we recommend if we are reviewing a workload where, for example, the dev environments and the staging environments are all exist in the same AWS account as the production environments. So in this case, you've got multiple accounts under a sort of account tree. And if you're familiar with things like LDAP or Active Directory, you recognize the terminology here. You have multiple accounts, but with a single billing relationship. So the root account is still paying your bills, either by invoice or by credit card, depending on what you've got set up. The subordinate accounts don't then have to worry about payments themselves. In the event that let's say you're using separate accounts for your live and staging workloads. If you bugger something up in staging, you can be reasonably confident that you haven't just put live at risk as well, as long as you've made other design decisions that support that. But so you're sort of limiting the blast radius of the change. One thing we like to do is to provide a sandbox account per developer. So everyone on my team has one or more sandbox accounts that they play in. And in this model here, you can see the OU. The OU is an organizational unit, and the developer's organizational unit has my sandbox and Salma's sandbox underneath it. And so it's very easy for someone to see that maybe I've accidentally left an EKS cluster running and it's costing money every month. That's from a cost allocation point of view, doing that on a per account basis is really easy. But also I'm not then causing problems for the other developers. I can do what I want in that account pretty much. Although there is here a service control policy attached to that organizational unit. The service control policy is a bit like an IAM policy, but sits above the account level. So even if I'm the root user of a developer account underneath the developer's OU, then the service control policy can limit me from, for example, starting resources that are too big, or using regions that are not Frankfurt or something like that. Service control policy is a really powerful way of managing per account permissions, even for those users who have root accounts there. Worth looking into. They're a little complex compared to IAM policies, but they're pretty powerful. In this model, there's a single separate account doing the single sign-on and the SAML federation stuff we talked about before. And in the case of the live account that's displayed here, someone with the developer role in the single sign-on account is able to assume the developer role in the live account. And pick up a trust relationship policy, which means that, for example, a developer might be able to log into live and possibly read access or read-only access to certain services, but not write to them. And maybe in the staging account, they might have access to more ability to make changes. And so there's the whole sort of single sign-on story can be federated across multiple accounts as well in that manner. In this example as well, there is a separate security account with a security log bucket attached. In the sort of best practice way that we talk about, that security log bucket is writable by role principals or service principals in the other accounts, but those accounts can only place new information in that bucket or append to those files. They can't delete or modify the files. The security account also doesn't have that federated identity setup enabled. So the security account there is used to provide a place where logs can be written but not messed with. And also can't be viewed by most individuals. And in fact, with the right security settings, you can configure it such that that bucket cannot have anything deleted from it at all. That's a recent change, and so you can see if you're in a compliance regime that requires you to have fully non-repeatable logs activity on the platform, you can achieve that in this way by making those design decisions. And that you can make assertions to your auditor that that is the case, and demonstrate that it's not possible to delete log data, and that's a really, really strong compliance position to be in. So if you're not doing multiple accounts under AWS organizations, it's probably something that you should look at, and we could help you with that if you were looking for some help. Really, one of the biggest things I want you to take away from today is that you have to teach your teams IAM. It's a foundational, fundamental part of the platform, and lots of people get it really badly wrong. It's really important to get right. There are plenty of blog posts out there that have you sort of copying and pasting really, really too permissive permissions into your IAM policies, and often those things will creep into production unless you know what you're doing. So please teach your teams IAM. One of the things that we offer as part of our support and learning package is workshops, and one of the workshops that we run frequently is an IAM fundamentals workshop to cover all this stuff with your team. There are some sort of worked examples, and teams will go away with a much better understanding of like why they should be making those good decisions. So do consider that. I'm going to talk about instance profiles now. So Matt asked a question about applications needing MFA and not. So to Matt's question, if your service is running inside AWS, and so it's not a third-party tool that you're providing some keys to. This is a thing that is running on your own servers. Then instance profiles is the pattern to be thinking about. And we frequently find in well-architected reviews that teams don't really know or understand instance profiles. What this allows you to do is to not ship security keys in config files or bake them into applications. It means that you don't have to create IAM users for application components. So the way this works is that the instance is running your application, as in this diagram here, and has access to something called the instance metadata service. And the instance metadata service has the ability to provide to that application some secret key material, and that secret key material is based on the role that the instance has been passed to. That is my doorbell. If you'll excuse me for just 1 second. Hello? Yeah, come in. Okay, cheers, Jess. Apologies, I knew that would happen. So where were we? The instance metadata service can vend tokens to the application, and the tokens are associated with a role that you've assigned to something called an instance profile when you've created the instance. And the role then has IAM permissions attached to it, which then dictate what those keys permit the application to do. So the application in this case is writing to an S3 bucket. So maybe I've got an instance profile that's got a role attached to it that lets me read and write S3 objects from a particular bucket. When the app starts and uses the AWS SDK, if you don't pass any kind of security credentials to that use of the SDK through either environment variables or sort of baked into the code, then that application will automatically go to the instance metadata service that is at a known address and fetch keys if they're available. And so you can see in this way that the application picks up the ability to make calls against the AWS APIs without having to put any of that key material into config files or baked into code. That's a really powerful pattern. It's actually much easier than managing keys in config files and so forth as well. It's a really great way of doing it. I've mentioned EC2 here. The same pattern applies to Lambdas. The same pattern applies to Fargate containers. The same pattern applies with extra steps to Kubernetes pods running in EKS. So this model is available pretty much everywhere. So if you have keys, if you've got any users in IAM that relates to services that you have running inside your AWS environment, then you cannot do that, and you probably should not do that as well. If your application is then requires secrets to talk to something off network, so API keys to talk to remote servers of some kind or services, then you can use Secrets Manager or Parameter Store with this instance metadata service. So your application will go to the instance metadata service, get some keys that it can then use to access secrets within Secrets Manager, which are then only available to that application based on the IAM privileges that application has access to. So really powerful. Please look into this if you're making calls to other APIs from your applications, and especially if you're otherwise baking those credentials into configs or applications. This will really help. Talking about least privilege before, this is an S3 policy for manipulating S3 buckets. When I originally copied this from a web page, this was the first non-AWS page that matched S3 policy in Google, and it was some instructions on how to set something up. This is awful. This is you can do everything you like to any S3 bucket permission. That's not a well-scoped option. This is the equivalent to chmod 777. If you were managing a PHP website and you wanted to handle file uploads, everyone that you found on Stack Overflow was like, yeah, just chmod 777. No, that's too open. That allows too many things. We see this sort of stuff all the time. It's pretty awful. And a good sort of review of your IAM policies will allow you to sort of break this down. One of the things we do as part of a security review is use AWS tools to see what changes or to see what API calls are being made by which principles, and then use that data to trim back the policies of those principles to only the bare minimum they need for those changes. So it's a really easy piece of work for us to do, and it generally improves matters a huge amount. Really, what you're protecting against here is that if for some reason or somehow those credentials leak out of the application, you don't want them to have broad-reaching access to S3 buckets in the way that this policy allows. So in case the message hasn't gone in, teach your teams IAM. Like, this is the really a foundational, fundamental part of the platform, and one of the things that people get very wrong very often, and it is avoidable with a bit of education. So please do consider looking into that in a bit more detail, and come and talk to us if you'd like us to run some training for those individuals on how to do that. So here are the questions. As I said, I'd give you a takeaway. Your IAM might need some improvements if you're logging in with the root accounts, if you have more than one identity for a single person, if you're not using roles for compute services, if you're not enforcing multi-factor authentication, MFA, if your apps have secrets hard-coded into config or code, which is worse, then you might need to improve matters too. If your IAM policies have a lot of stars in, that's a smell for overly permissive policies. And actually, a lot of the AWS managed IAM policies are guilty of this. So if you're using a lot of the AWS managed IAM policies, then you might be unintentionally scoping your IAM policies a little bit too broadly. So do go and have a look at that. That's a good first place to start if you're worried about your security posture at all. So the second area is detective controls. And these are tools that help you identify a potential threat or an incident. And they work mostly by establishing a baseline and then looking for anomalies against that baseline. And the first sort of most obvious thing, this is something that we learned in the DevOps world a long time ago that people still not doing as broadly as I think we would like, is to log everything. Like get data out of your services and into somewhere where you can look at it. CloudWatch logs. So if you're generating application logs on your instances, then funneling those logs into CloudWatch logs will let you have a better understanding of what's going on there. CloudTrail. if you don't have CloudTrail turned on, that's a really easy thing to do and really beneficial. CloudTrail logs every API call that is made that makes change to your platform against the AWS APIs. So those S3 bucket manipulation things that the app we were talking about previously was doing, that'll be in there. It logs changes that your staff make in the AWS console. It logs changes that they make on the command line, logs changes that they make through API calls. Like CloudTrail is a font of useful knowledge. It's really good for debugging IAM policies as well. But from a kind of observational perspective, from a security point of view, it's something you really need to be turning on. There's also VPC flow logs, so you can log network traffic, the shape of network traffic within a VPC. Not many people know that exists. And DNS query logs, so queries against your Route 53 resolvers can also be logged. Most people know about CloudWatch logs. Not everybody knows about everything else. I mentioned in the organization story earlier about having a central logging account to append log data to. This is the sort of log data we're talking about. You might not want to keep everything forever. You probably want to sort of think carefully about your aging out policies and so forth. But having everything available to you in log files is a real time saver when it comes to troubleshooting. There's no point catching those logs if you're not doing anything with them. Using the ELK stack or other vendor tools gives you good access to slice and dice those logs. Matt's asking, do you find most people find the CloudWatch logs interface sufficient for interrogating logs? No, it's kind of awful. Most teams that are doing anything serious with logs do like to use other tools, whether that's ELK or a third party, something like I don't know, Honeycomb or logs.io or Datadog or whatever. If you've got your logs in an S3 bucket, you can use Athena to query them, particularly CloudTrail logs are all JSON format. And so Athena finds it easy to kind of slice and dice those, get real value from them. You can also funnel logs into Kinesis streams and do interesting kind of processing things on them using Lambda and all sorts. Really, there's a whole bunch of things that you can do that are interesting with log data that I won't go massively into. But think about not just providing dashboards for the humans, like you use some automation to do things with those logs if that's something that you can do. If you need to redact items of personally identifiable data from logs before they are stored or visible to anybody, maybe consider using Kinesis for that. You can manipulate the logs as they pass through your Kinesis stream, and you can sort of pick out things that look like credit card numbers or dates of birth or email addresses or whatever. There's all sorts of stuff you can do there. Processing logs can be quite expensive. If you think about a single API transaction against a standard web app, that could well back off onto multiple systems and produce multiple activities going in the back end, each of which will produce at least one, maybe more lines of log data. So often logging infrastructure can be bigger than the infrastructure that you build your application with, and you shouldn't be surprised about that. It's often we'll often have conversations with cost sensitive individuals in some companies who are really concerned about what they're spending on their log data compared to their application because they don't see it as valuable. Well, there is value there, and in the security and compliance world, there is even more obvious value because you sort of have to store those things forever for your to appease your auditors. But processing logs can get spendy. One really cool AWS product that came out recently. I don't usually effuse about products in this sort of way, but some things, every now and again, you get something released that just looks a bit like magic, and GuardDuty was one of those things for us. GuardDuty watches activity against some of those log sources, so things like CloudTrail, and actually works regardless of whether you have CloudTrail enabled, I think. Because the data is still inside AWS somewhere, even if you're not pushing it onto S3 buckets. GuardDuty watches your log data and flags anything that looks unusual. It's using hand-wavy machine learning magic, so I can't really tell you anything about how it actually works, only that it really does look like magic. So this example I've pasted here. The first customer we enabled it for was a financial services business, and they were working in level 34 in Canary Wharf, and they were doing business in other parts of the world. So they went to Asia, and so the CTO that we were dealing with had hopped on a plane, gone to Asia, and at that point logged back into his laptop and started hacking on his AWS infrastructure, and GuardDuty lit up like a Christmas tree and said, hang on, this person doesn't usually connect from these sets of IP addresses. And so we were able to kind of go, spawning your team in, Asia, like that's weird, and sort of confirm that was actually usual, normal behavior. The second example is, if you've got users who don't typically manage other IAM users and they start doing that, then that can flag as well. The most recent cool thing that we saw out of GuardDuty was one of the teams we've been working with was connected to the Tor network, which some of you may know about as a sort of accessing the dark web, if you like, but for whatever reasons he was doing that. He was doing that whilst connected to his VPN that was running on AWS, and so GuardDuty saw Tor exit traffic coming from their AWS account because of the way that his home traffic was being routed at that time, and flagged up as hey, this is a bit weird, you probably want to look into this. Can't speak highly enough about GuardDuty. It's really quite something, and it's easy to turn on, and it doesn't get too noisy. These are fairly well tuned alarms, and it's good to sort of get an idea of when unusual things are happening, because sometimes there'll be normal unusual things, but sometimes it will be actually someone from Asia hacking your stuff. So turn that on. It's nice and easy. Have a play with it. Since I last ran this slide deck, there have been a couple of new security announcements. I can't tell you a huge amount about these services other than what's on the website, because I mostly do spreadsheets, email, and webinars these days. But the AWS Security Hub is a comprehensive view of the high priority security alerts and your security posture across your accounts, so multiple accounts. It aggregates, organizes, and prioritizes those alerts and findings from multiple AWS services. So it's like a central point where all this information is aggregated, so you're not having to kind of wire up lots of different GuardDuty alarms across your multiple accounts. They're all visible in a single place. And the second thing, which went general available maybe last week or 2 weeks ago, is a platform called Amazon Detective, which provides you a unified view of those events. So again, sort of centralization of that data, but with a sort of dashboards and things that you can then sort of do root cause analysis over and dig into what's been going on. So if you get alarmed on something from GuardDuty, then Detective will let you kind of hunt through information to more quickly find out where that came from and why. There are visualizations and so forth as well. So I'm hoping to get a chance to play with that at some point in the near future. You should probably do that as well. So your security controls may need some work if you're not logging anything at all, or if you're not logging enough. You might need some work if you're not alerting on important log conditions, so things like GuardDuty and so forth. If your logging alerts are noisy, like there's too many of them because they're sort of not well tuned, or your team is ignoring them, and often those two things are related, then they're not doing their job. So you need to kind of stay on top of classifying and doing things with those alerts, such that you are only getting alarmed on things that are actually worth looking at. And if you only use logs when you're debugging, that's possibly a smell as well. I think it's good to look at logs in the general course of things, like see what's happening. What does normal look like? Are these logs noisy even when things are working properly? Can you tune those out? Those sorts of things. So do consider logging and turning on some of those security detective controls, because for the most part they don't take a lot of configuration. They give you a lot of value. So I think the third section is the infrastructure protection. So these are your architecture patterns, really. These are sort of how you design stuff in order to protect your data assets or your users or whatever. This is the sort of the most obvious and sort of foundational thing if you're building things inside VPCs, which not everyone is now, but in the sort of EC2 or Fargate landscape, you're likely to still be thinking about VPCs. And this is from an AWS blueprint about designing VPCs. So here you've got a VPC that contains, in this case, 4 availability zones within a single region. And those availability zones have been split into public and private subnets. Actually, there are 2 layers of private subnets here for some reason. That's not always the way, but what we're saying about this pattern is that the only traffic that can get out of your private subnets must do so via the NAT gateway or a NAT instance in the public subnet. So once you've got this pattern in place and the routing tables and the network ACL set up properly, nothing can get out of your network unless you have permitted it through those public networks. Likewise, nothing can get into your network unless it comes via something that lives in the public network. And so often the public network will contain possibly bastion hosts if you need to get into administer services. Or that's where your load balancers will live if you're balancing against balancing web traffic, for example, into your private subnet. So this is your kind of standard layout, and you'll see this pretty much everywhere in all the blueprints. We have a reference architecture that we've used for a number of years that looks more or less exactly like this. If you're using VPCs and you have a security posture that you care about, and it doesn't look like this, you might have some work to do. Often we find in well-architected reviews that this understanding of public and private subnets and traffic routing and so forth is overlooked, and everything instead runs in a single public subnet. Often, again, this is sort of bad tutorials on the internet where it is actually more difficult to get things up and running in a properly secure manner. And so to demonstrate the thing that they're trying to talk about, they provide a sort of example architecture that has everything sat in one availability zone in a public subnet with public addressing attached to it and everything. That's pretty fatal. We definitely recommend re-architecting if that's the case. You can mitigate the pain of that in some ways, but it's better to rethink, really. Security groups are the other thing you've probably come across if you're building sort of more traditional looking infrastructure. And a security group is, you can think of these as firewalls. I mean, they're sort of not exactly, but that's sort of where they sit conceptually. You can have more than one security group attached to a resource. And those security group rules can permit or deny traffic inside the group, traffic between groups, traffic to and from network address ranges, and you can put those limits on by port and by protocol. So very much like a firewall rule, really, but with this sort of idea that you can talk about other groups as a source or destination as part of those rules. The example that I've diagrammed here is, you might have an application that has a database, and you might have a second application. It is possible, for example, to put the application and the database in the same security group, and that might be appropriate if the data that the database contains is all related to that application. There are various ways of thinking about this, but if you're not using security group rules and you have deployed EC2 instances or Fargate container things, then you might have some work to do there as well. The other sort of protection design things is fine-grained IAM policies. So we've already talked about IAM a little, but there are also ways of attaching more complex policies to other parts of the AWS ecosystem. So if you're using KMS to manage keys, key material, you can attach a much more fine-grained policy to KMS to further limit the access of principals to those keys. Same with S3 buckets, where things are public and private and so forth is manipulated by an S3 bucket policy as well as IAM policies. SNS also has some access controls around it. I think there are now like one or two other services where fine-grained policies are available compared to when I originally wrote these slides. But if you're using a service, do go and have a read at the security bits of the documentation, because they will be instructive on how best to hold those in a least privilege kind of way. Direct Connect is another sort of architectural pattern if you are running stuff on premises in a data center. I don't know how many of you would still doing that these days, but connecting from a data center out to the cloud, you can use either a wired connection in a physical point of presence, or VPNs that are set up to behave a little like that. If you have a higher throughput or a lower latency requirement than you can get over the public internet, or you're pushing a lot of data and you want the cost savings of that, or you want an increased level of safety around the encapsulation of your cross internet data, then Direct Connect will give you those guarantees. And you can access either private or public resources over that link. So you can route your data center outbound traffic out via resources in AWS. So we see some customers who send all of their corporate traffic over the Direct Connect link and out to the rest of the world via scanning or other security infrastructure on the edge of their AWS network. So that's all an option. Most companies don't need Direct Connects, is probably my view, but for specific use cases, you might. Other protection things you can turn on. So AWS Shield, that's provided by free and default to users of CloudFront and ALBs, and I think NLBs as well. So if all of your applications are hidden away behind those sorts of networking services, then you get denial of service protection from Amazon by default. You can also upgrade that to Shield Advanced, which gives you way more control over the type of traffic that's limited, and access to AWS's own security engineers for sort of tuning against denial of services. So if you are likely to be a DOS target, then Shield is the right thing to do. It is for that reason that we don't generally recommend these days putting EC2 instances out on the public internet just by giving them public IP addresses, because then they don't get that DOS protection. You'd want to put those behind an ALB or a CloudFront distribution in order to benefit from that network safety. There's also AWS WAF, which is a web application firewall, and turning that on acts as a layer 7 filter for HTTP requests, and you put that in front of your web applications with either a rule set that you've built yourself or a managed rule set that you've bought from a marketplace seller. And the layer 7 filtering will filter out things that look like malware or bad requests. So one good example of this, if you are burdened with a WordPress install, there are web application firewall rule sets that will mitigate against the types of SQL injection or cross-site scripting attacks that appear commonly against WordPress versions, and so sort of protect those things at the edge. So we don't see a lot of use of WAF. We have in the past used non-AWS WAF services with clients. Sometimes it's more trouble than it's worth. Depends what you're building. One client we work with, their API, basically the normal API traffic looked like SQL injection to the sort of managed rules that we'd installed, and so we ended up just turning it off because it was pointless. AWS Inspector is something that you should have a look at as well, particularly if you're running, or I guess only if you're running EC2 instances. This is part of Amazon's Provable Security initiative, which is about automating security proof against infrastructures. I don't think I've ever seen this in use in a well-architected review personally. Mike may well have seen some of this, but it runs on an agent in your EC2 instances, and it will scan for network reachability. So it will look to see whether it can get traffic out to the rest of the world. It will check those hosts against known CVEs, so security issues that are known about. It'll run a continuous check against the CIS benchmarks, which are it's a benchmark for configuration hardening, turning off certain password rules and other bits and pieces. And it checks against other security best practices as well. That's evolving all the time. And it can also analyze the application runtime behavior. So if you've got an application that's been compiled using flags for your compiler that make it a little too possible for the runtime part of the application to also write to that memory segment that also has other code in it, it'll flag up on that. And there's a bunch of smart checks that it's doing in there. And if you really care about your security posture, then that's definitely something to have a look at. There are obviously vendors who are offering you security tools as well, and some of these are worth looking at. Sneak are friends of ours. We've worked with them a little bit. They provide a mechanism for scanning containers and scanning GitHub repos, looking for out-of-date dependencies or dependencies that have CVEs logged against them. So this is part of what you call a shift left approach to security, where you're taking the some of the security testing that you might do and doing it as part of your software delivery lifecycle rather than just on the places where it runs. When I've given this talk in public, we've had customer stories and customers there to talk about them. I don't have any of our customers here today, unfortunately. But one case study, we've worked with a team called Search Pilots, who were actually called Distilled when we first worked with them. They built an optimization delivery network that transforms website traffic so they can do testing for SEO changes and marketing rules and so forth. And because of that, they sort of sit in the request path for e-commerce platforms, and as a result see plain text credit card details pass through their platform. And so they needed to be PCI DSS compliant at the highest level. We worked with Search Pilot to ensure that was the case by adopting some of the security stuff that we've talked about today already. We also adopted alert logic for scanning some of their network activity, and that got them through their PCI DSS level 1 review quite happily, and they ran safely and securely after that. I won't go too far into that. If you want to talk a bit more about the case study, then Mike might have some details about that, or I can answer questions by email if you'd like. So what about serverless, you might be thinking? I think when I first wrote this slide deck, serverless was a bit less popular than it is today. So serverless obviates the need for some of what I've talked about today. So you still need to worry about IAM, but because if you're wholly serverless, you're not running EC2 instances, you're not responsible for operating systems, and if you're not responsible for operating systems, then you have no things to worry about patching there. You obviously still have to patch your application dependencies, but there's no OS to worry about. You also don't need to run inspector because there's nothing going on instances to worry about. So serverless as a pattern for security is probably a good thing, but there's additional complexity involved there as well. So your protection here might need work if you've got anything other than load balancers or NAT gateways in your public networks. If your security groups are too permissive, like they let too much traffic to too many places, then that might need improving. We can review those for you if you're interested. If you mostly use CIDR network ranges in your security groups, we've seen this a bit as an anti-pattern. That's probably not correct. If you're not protecting your application with WAF, you might want to think about doing that. If you're not scanning for vulnerabilities actively, and in particular if you're an EC2 user, then you probably need to do some work. And if you're not checking the dependencies of your applications for their security, then there's probably work to be done in your software delivery pipeline as well. So let's talk about data. So data protection is really about limiting access to and encrypting data so that it's safe. We find very few people do this, but it's probably important to classify the data that you hold. So look at the data you have and figure out like what classification level it lives at. So is this sensitive or personally identifiable, or is this financial data, and so forth. If you can tag the resources that are responsible for using or processing data at different classification levels appropriately, you can make assertions about where that data goes, and you can sort of look at a diagram or look at the tooling and go, I know that this system has personally identifiable data in it, therefore I probably shouldn't be allowing these types of people access to those systems. You can use KMS keys per classification level. So one good way of limiting access to particular types of data to particular types of users would be to use a KMS key to encrypt your sensitive data that may be a different key than you're using for your less sensitive data, and your sensitive data is then going to be used by the KMS permissions might allow certain individuals access to that KMS key, but not others. Sorry, Andrew Reed has asked in the Q&A, if you mainly use cider network ranges in your security groups, can you elaborate on that, please? That's from my slide about security groups. Yeah, so if you're using cider network ranges in your security groups instead of referring to other security groups by their ID, then you might have got mixed up somewhere. So if your cider network ranges that you reference inside your security groups are mainly for network ranges that are inside your own AWS network, then you might not be building those rules as flexibly as you could be. If your security groups reference cider network ranges that are outside your network or on your on-premises environment outside of your over a direct connect link or something, then that's probably okay. What we've seen is teams creating network ranges inside their availability zones, and then using the cider network ranges of those networks in their security groups instead of using references to other security groups, and that's not a great look. Mike can maybe elaborate on that with a couple of examples in the chat if he's up for that. But thanks for the question, Andrew. That is a good question. So back to data classification. So limiting access to data that is sensitive only to people who should be able to see sensitive data is something you can achieve with KMS keys and access controls on KMS. You should probably control principal access to keys and resources. So, not allowing all users access to all KMS keys will help you kind of do what I just mentioned. You can also consider tokenization. That's an application side consideration where you are tokenizing the sensitive data that you've got in your app before you store it into a database. There are vendor tools that will do that. I can't speak to how useful they are or whether that's necessarily better than doing those things with KMS, but it's an option. I believe HashiCorp Vault has some options for that. And AWS Macy is worth looking at. It's another machine learning tool from AWS, which will help you look for sensitive data in at least S3 buckets, possibly more of the storage services now. These slides are about a year old, but it will look for things like PII, intellectual property, keys, credit card details in your S3 buckets, and an alert on those. So that might be worth running periodically to be completely sure that you don't have sensitive data where you don't want it. That applies particularly to log lines and that sort of thing. Data that is at rest, you should think about encrypting. Almost every service that can store data has an option to encrypt at rest, and it is really just one click away from being enabled or one change in your config management tooling. You should limit personnel access to data, so use IAM to prevent developers getting it production data if they don't need it. And using those IAM policies will allow you to assert that you have put in that limitation when you're talking to your auditors. If you're building EC2 instances, and you want to be completely sure that all data on those EC2 instances is encrypted at rest, you can take a base AMI and copy it with encryption turned on into each account that you want to use that in. And then every piece of data that you're storing on EC2 is going to be encrypted as well. That's not the case out of the box. You have to copy those AMIs. Very easy with Terraform or CloudFormation. You should protect your secrets, so do consider AWS Secrets Manager. I mentioned that briefly in the sort of instance profile section earlier. Secrets Manager lets you store secret data in sort of structured JSON format against a key, and then limit access to who can get at those secrets by principal using IAM. Secrets Manager will also rotate secrets for you, so that there are ways of managing the life cycle of API keys or database keys, so that you essentially end up with rotated keys every week or every day or every hour. And so if your application accidentally leaks key material, the scope of those keys are time bound for the amount of time that it takes to get those secrets rotated. So for high compliance environments, it's definitely worth looking at. And it's an interesting sort of challenge from a development perspective to think about key rotation and that sort of thing. So maybe you'll be able to get your developers interested in that by looking at it on a hack day or something. Temporary RDS tokens are a variant of that, but RDS generates its own has its own service for doing that. Though it's recommended that you only use those temporary tokens if you are processing batch jobs infrequently, rather than doing it in the main request path of your application. Parameter store is another way of storing parameters on a per application basis. You are able to also encrypt secrets and store those in there as well. Again, controlling principal access with IAM, you see how frequently IAM comes up. Preventing certain principals from getting at certain secrets is an IAM consideration. You've got to know IAM, as I think I've said a few times. And there are vendor solutions for this as well. So HashiCorp Vault I've mentioned, things like CyberArk and others are available to help in some of that way. Data in transit as well, so stuff that's traversing a network, using HTTPS listeners on load balancers, using HTTPS on CloudFront, using certificates in Amazon Certificate Manager, and using VPNs where necessary, although you can encrypt data in transit from your sort of private VPC services without using VPNs in a way that's really user-friendly and can be bolted together with your federated identity services. We use that internally to protect our documentation and our monitoring services, but without our users having to connect to VPN. So we can talk a bit about how to do that if you'd like. Backups is another sort of data protection consideration. Like, you should be using the features that are provided for backup. You can replicate data to other regions as well if you want to avoid the consequences of a full region failure. You have to intentionally turn that on. No data will leave a region unless you've explicitly requested that happen. And again, like, while you're thinking about access control, don't forget that if you are not allowing certain developers access to data services, you should also prevent them accessing the backups of that data service. Be surprised how often that gets missed. If you're replicating data to another region, there are implications with KMS and key management. You have to make sure that the keys are shared as well. We've done a bunch of cross-regional backup services for people. We can help you with that if that's a consideration. So your data protection might need some work if too many people have access to too much data. If you're not thinking about classification, if you're not encrypting at rest, if you're not encrypting in transit, if you're storing secrets anywhere than in AWS services, if you don't have complete backups, and if you haven't tried restoring those backups, then you should probably consider doing that. Let's look at incident response. So what do you do when a security thing happens and something goes wrong? Well, you can automate responses. Like, if you've got CloudWatch events firing on certain actions, you can have those send notifications to SNS and then trigger actions in Lambda or step functions. So you can take automated reaction, or automated response on certain types of incidents. That might be a good thing to do. We know of teams who use, if a customer or if someone on their dev team logs in via SSH to a machine, that can fire a CloudWatch event that can cause that machine to be torn down after an hour because it's considered to be tainted. So that's a really smart way of preventing tinkered with machines from being in production. Also think about clean room access. If you're going to have to do any kind of digging into problems that have resulted from a security incident, you're going to want to have forensic tools already installed on the instances that you're running. You're going to want to be able to allow a security team or security individuals to get shell access to those resources, so they'll need user accounts on those EC2 instances. And you probably want to quarantine things that are suspect. So deny them any network outbound access, take them out of security groups, take them out of auto-scaling groups, maybe take them out of a security group and put them in a security group that does something else. That sort of automated quarantine means that you can take that thing that's been compromised, move it somewhere else to look at, and know that you can do that because it's already got all the tooling that you need on it. One well-architected finding that we have here, there's almost no teams really writing good runbooks or playbooks about their incident response. A lot of it is guesswork. So do think about how you would build an incident response approach, both for support in general, but particularly for security. Make sure you've got people who are on call. Drill those individuals to make sure that they know what they're doing in the event of an incident. So if incident response, your incident response might need some work. If you can't remediate common incidents automatically, if you can't quarantine bad nodes, if you don't have engineers on call and they don't know how to respond to on-call alerts, and if you don't regularly practice incident response, then you might need to do some work here. So I know what you're thinking, John, there's a hell of a lot here to think about. Yes, that's entirely true. AWS are quite good at providing building blocks and requiring you to think about how to put them together. They have also provided something called Landing Zone, which is a set of cloud formation blueprints for setting up a lot of these things. So the multiple accounts under AWS organizations, the SSO relationships between them, the sort of centralized secure logging account and so forth. Those are all provided by Landing Zone. Landing Zone will also configure some detective controls and set up CloudWatch alerts and use AWS config for watching for changes to setups against a particular compliance regime, and also some opinions about managing identity. There's quite a lot in there. Landing Zone also provides you with sort of baselines for accounts and networks, so that users within your organization can use a sort of account vending machine in order to create new accounts that already have all of these things set up. There's a lot to it. We've done a bunch of work with a business called Essentia Analytics, who are a fintech business dealing with potentially sensitive trading data, and we got Landing Zone set up for them so that they can create new accounts for their customers in order to prove to their customers that their data is kept safe. And we can definitely talk about that in a bit more detail. But actually, Landing Zone is quite a lot to think about as well. So you might have heard AWS released relatively recently a service called Control Tower. It was at the beginning of last year, I think, or sort of mid last year time, and that provides a lot of those sorts of Landing Zone opinions about how to create new accounts and set up their SSO and their log aggregation stuff, but without you having to build out Landing Zone yourself. So if you're thinking about building out multi-account setup, or you're thinking about rethinking how you do your account architecture, Control Tower is definitely something to look at. We've got some experience under our belt in that if you'd like some help. It also allows you to sort of build on top of their own opinions and add other blueprints to support your own needs. So definitely worth looking at if you're in some kind of security mindset. What's next? Like, where do you go from here? You can talk to us about training, consultancy, well architected, maybe migration if you're trying to move to the cloud, or in fact, if you're building something new, we can help you with that. I mentioned earlier that well architected is a particular strength of ours. If you book a well-architected review, we can dig into the security stuff that you're doing, and if security is your main consideration, we can tailor our consultancy around that. A well-architected review is free, and beyond that, if you book some work with us to improve your infrastructure after having been reviewed, then there are $5,000 worth of funding credits available to you to support that improvement work. And that funding model applies to every workload. So if you're running multiple different types of things on AWS, we can review them all separately, and that $5,000 is available for each. There are other funding programs available as well if you're migrating and so forth. Those are only really available through partners like us. So if you are doing something new on the cloud, or you'd like to get an understanding of how well your practice is going, then that's a well-architected review is a really great way to start the conversation with a partner and see what we can do to help you. If you've enjoyed sort of listening to me, but you'd like to be a little bit more kind of interactive in your discussions with people who do practice AWS stuff, we run a monthly hosted discussion format called Breakfast Ops. Prior to our lockdown situation, we used to run that in the office and provide breakfast and tea and coffee and stuff to a discussion. We're running those online now, so if you are interested in joining discussion formats, then please let me know after this, and we'll get you signed up. And now we have 3 minutes left against the allotted time, but we can stick around a little longer if anybody has any further questions. I can see the little orange box at the bottom showing that Mike has done a sterling job of keeping on top of those whilst I've been chatting. But if anybody has anything else to ask now, type it into the box, and we'll see if we can get it answered. Okay, sounds like we have satisfied your need for knowledge today. Do keep in touch. My email address is there. You'll hear from us after the webinar anyway, with some details on how to get in touch, how to book a well-architected review. Thank you for your time. I hope you've found something useful from here. Please do stay safe. Keep your hands washed. Be lucky, and hopefully we'll see you soon. Thanks for your time.